I didn't do one of these for kindergarten. So if you know me, it's probably because we have older children. I do these math sessions for first grade through fifth grade for the important units. I shouldn't say the important units, they're all important, but for the math, the numbers units. Geometry and measurement are usually so hands-on and so straightforward, that's not where the difference is, and parents are fine with it. So today we're going to be looking at adding and subtracting through 20. The first unit was up to 10. It really was a review of kindergarten, but we know how much kids lose over the summer, and especially the younger they are, the more they seem, so we do that review unit. Before we get into the math, looking around, I need to get on this, I call it my soapbox. Really the most important thing that you can do to support your child is to show an enjoyment of math. Find out and show where it happens in real life, because that's especially valuable at the 5 and 6 and 7-year-old level. At those levels, we kind of need to show them where it is. And I don't know if you can remember, I remember the day in Algebra 2 where I finally went, where in the world would I use this? And it's when I lost my interest in math. I gained it back later, but we need to have the kids making this real. I'm very pleased to see fathers here. This is kind of, to be honest, a very high ratio. I usually get 2 to 3 fathers. In lower grades, most kids go to their moms. Great. If by chance you are a person who's not comfortable with math, it's time to change your attitude. There is no such thing as a brain that does math well and a brain that doesn't do math. There are no little sections, there's nothing in our DNA, there's no spot in the brain saying yes and no. You may not have been taught well, you may not have been taught in a style that you did it, but everybody is capable of learning high-level math. It's frustrating when we don't understand it. It's going to be frustrating for your child at some point in their life. Running into some hardship, that's not a problem. Learning how to get through a struggle is probably one of the most important lessons we learn in our life, instead of just throwing our hands up and saying, I don't know how to do it. So please, when they come to you, if you're in first grade, help them out. It should be fun. Smile through the hard. I don't know that it's that hard in first grade, but to your child it may seem it. Rejoice when you get through that. Absolutely admit that it can be hard. And I'm again looking at the audience. The Western world really has this thing about, oh, go ask your father, he's the one that's good at math. I'm pleased to say mostly Asia and stuff, they don't have that attitude. We've got to get rid of that attitude. You've got to say we're all capable. Please don't give an image to your daughter that math is for boys and not for girls. No one of us would do that, right? Okay, the other thing is I'm going to show you about a 6-week unit. Your kids have not gotten this far. Please don't go home and take the very last problem and try to solve it with them tonight because you're so excited and you want to have this joy of math with them. Please be aware that they're taking 6 weeks. Also, you may not really master what we're doing because I'm going to give you 1 or 2 problems and we're going to move on. Please, your kids are taking days to practice this. I am going to show you how to use manipulatives, but we might move on quicker. In the classroom, your kids will have these manipulatives available to them all the time. Some kids will need them longer than others, but we always learn new concepts with manipulatives. We then move to manipulatives and making a drawing of it. We might we keep making the drawing of it, and then we add the numbers in. We get to the numbers. I promise you, your child is not going to leave 5th grade needing to carry around blocks. They are going to use the blocks because it's appropriate developmentally. Manipulatives are not for the slow kids. We use them when it's a new concept. When your little one, in a blink of an eye, is in 7th grade, they're going to be using manipulatives because they're learning a new concept. They're also going to be using the same strategies that we learned down in elementary. How we make an array is the same thing as how you can add x plus y. So these strategies that we're teaching them that your child might not need to solve this particular problem, we have a real good reason why we want them to understand the strategy. Because it's going to be transferred over to repeated addition. Repeated addition is multiplication. Multiplication of numbers is done the same way as multiplication with decimals, is done the same way as x plus y to the power of 2. So we're teaching them these strategies that work for the rest of their mathematical career. I've heard a calculus teacher explain how they're related also, and he lost me because at that point it was beyond my math. They were using manipulatives all the way through. So if your child is saying, but I don't want to do it because I know the answer is great. I want you to make your answer visible to me. We love mental math. We want your kids doing mental math, but we also want to be able to have them explain how they got the answer. So this packet at the very front, you can reach me at this email. ASD Parent Math Resources is a site where I put up this video, will be going up there. A copy of this problem set will be up there, and in a few days, actually I said for the video and the answers will be put up there, so that you can always go back, or if you have to leave early, or if you want to revisit. We won't do all the problems, so if you want to double check your work, I would say ask your child, but I shouldn't say that because they may not be there yet. There are other things up there, such as the strategy letters from your teachers. So I want to remind you, your teacher should be sending home I don't know what color, but it should be on color, a letter each unit about the strategies that are being taught. We are sending it home on paper on purpose. We value our trees, but we want you to have this so that if you sit down with your child to do something, or he or she's explaining something, you could be looking at that strategy letter. It should be put someplace handy, and that's why we don't leave it on just the computer, because we know that you're not going to stop a conversation to go look up the email to go find it. So the things that are on here are the way your child is being taught in class. I know your kids play games for a lot of their homework, but you might be seeing some work coming home that possibly isn't finished. I'm not quite sure individual teachers have a lot of say in that. Next page. We have a few math terminology. Some of them may be new to you. Some of them may just be that you haven't had to think about them for a while. Math facts to 10, what do we mean? We mean those addition and subtraction facts. 9 plus 1 equals 10, 10 minus 7 equals 3. By the end of first grade, that's in June, we want your kids to have easy access to those. They'll probably know most of them. There are a few that seem to trip up most kids. I mean, there's some ones that predominantly are harder for kids, 7 plus 3. But by the end of first grade, they really should know those and be able to access them quickly. The best way of doing that is playing games. Flashcards, honestly, they're not fun. They're rote memorization, which for this isn't bad, but your brain does learn better when it's happy. There are literally chemicals that come out of the back of the brain when they're enjoying what they're doing. I'm not sure I've ever had a child come and beg me to play with flashcards. Will they go on to the internet and play this fishing game that says 5 plus 4, and these fish are swimming by, and one of them has 9, and one has 6, and one has 2, and they have to catch the right one, but they're swimming, so they don't really have time to keep counting it up on their fingers. Any card games you play, just keeping it natural and fun. At the stoplight when we all drive here, we all get stuck at stoplights. Look at the driver's plates, license plates around you. Look at the numbers. Can they add them up? You know, just kind of making it that routine of practicing them. Compose and decompose. They're the big math words these days. They mean exactly what you'd think. It means to put together is to compose something, and to take apart is decompose. So we use that. How can I decompose a number? How can I break apart 7 to help me with something? This particular symbol, we know it so easily. It's called the equal sign. It is actually very, very abstract to a 6-year-old brain. They get it because they think, oh, it means get the answer. It's actually not what it means. It means that an equation is balanced. That too is a little bit difficult for a 6-year-old. Same as, that starts making sense to them. 6 plus 1 is the same as 7. They're going to understand it. I know I can get the child to say 6 plus 1 equals 7. I would not be as positive that they understand it as much. There have been many studies that show if you ask a child by 2nd grade, can you see this? More than half will answer it 8. Because to them, the equal signs tell me, oh, I need to find the answer of 6 plus 2. Well, of course, if I then turn around and say, well, is that the same as? Is 6 plus 2 the same as 8 plus 3? They look at me and they're like, no. So we are really, we've switched our language. We want to get to language that they understand. Yes, we're going to get them to the equal sign and the equal language. We just don't need to do it at 6 years of age. We'll use it interchangeably so that they start understanding the connection between the two. So that's why this is on here. It's pretty important. I wanted to show you these 2 pictures. We talk about modeling or making the mathematics visible. This is called the number bond. It's also referred to a lot as part-whole. Many story problems can be understood if they understand the parts or what's being asked. Because if I know this is 13 and I know part of it is 3, I can figure out the other part. It's not necessarily addition or subtraction. You got a choice of which way you want to do it. If I know these 2, I can figure out the whole. So it's a model that the kids can use easily to make sense of a question. The next one is the 10 frame. It's just a way that we can lay out numbers. Our brain loves patterns. We use the 5 frame in pre-K. We moved to the 10 frame in kindergarten. It's a very brain-friendly graphic, and we get used to seeing it, and it amazingly completely aligns with our number system. So this idea that understanding tens is a friendly number, because your children by June will be going up to adding and subtracting up to 100. Well, they're going to start recognizing 7 tens and this, and we're going to be in numbers, but we're also going to be this way that they can visualize it. When your kids do story, I call them story problems, what we would say is the real mathematics. It's beyond just the arithmetic or the computation, but they're taking a situation. We decontextualize it. That's a very math type thing. They can take the words and they can turn it into a number situation. They can turn it into an addition or a subtraction problem. When they do that, we use a term, RDW. It's just something the teachers like. It means read the problem, draw what it means, and then write the number sentence, write the equation. We do use the term number sentence. Again, at 6 years of age, we're helping them out. But we do use the word equation. If your child likes it and understands what it is, it's fine. An equation is something that, again, is balanced on both sides, so it has an equal sign. The last 2, I bring this up because you did learn them, probably back in about 5th grade. You may never have used them again since by name, but we do this mathematics all the time. The commutative property of addition means that you can switch the order of the numbers, that 3 plus 3 is the same as 4 plus 3 is the same as 3 plus 4. We get the same answer. To be flexible in math, that is a wonderful property. It means I can pick the bigger number and then add on. So if I was adding 2 plus 13, and I still don't know how to do it, I don't hold 2 in my head and then try to add on 13, I'm welcome to shift it and do 13, add on 2 more, and it's a much more efficient strategy. The associative property, probably a little bit less known, means if I've got 3 digits or 3 numbers, I can add the 2 and the 5 first, and I get 7, and I can add 1 more and I get 8. Or I can add the 5 and the 1 together and get 6, add it to the 2, and I still get 8. So linguistically, we're associating different numbers together. We can do this for addition, and we can do this for multiplication. We cannot do it for subtraction or division. Both of those properties, or addition and multiplication. We are going to be using this rule, whatever I want to call it. We never use that term in front of your kids. I don't know, if a child asked me, I would surely give it to them, but we don't expect them to have that language. But these are mathematical properties. They have been proven at a very high level of math when you get into proofs. So we start doing this, and the kids find it quite natural. We prove it to them, but they prove it to themselves. But I did just want to give you the name with little expectation of your needing that information. Okay, today we might be using these. I'm going to ask you, you're going to have some choice of manipulatives. You may or may not use this today, but you at least have a copy of 10 frames that you could use at home if your child was working on a problem. So I was going to say, depending on whether you use the chips or the cubes, you may be using those. So one of the really, really big important ideas at this point in first grade is that 10 is a friendly number. By now, many of our kids have their facts up to 10 or have a lot of them, but they know that once they get to 10, they can keep working. So this is where they're starting in this unit. Bill went to the store, he bought 1 apple, 9 bananas, and 6 pears. How many pieces of fruit did he buy in all? We had him write it or draw it. 1 apple, 9 bananas, 6 pears. We, by now, have left the art class. When I say draw it, I mean in a mathematical fashion. X's, dots, but we're not drawing an apple, whatever, how many pears. So we are, to this point, we're beyond. In kindergarten, we needed to still let them draw something that represented the fruit because that's where they were at. They are now fully capable of knowing that a circle can represent these different things. So we asked them, can you find a way to find 10? There's a 1 and a 9. This is where they know these facts. So they put the 1 and the 9 together. They have to add 6 more. 10 plus 6. They'd probably do 10. 11, 12, 13, 14, 15, 16. They may add it. They may count up. So we've got 10 plus 6 equals 16. And we see how those numbers came together. At this point, they are building this first. Would you please build, and as I said, I give you things. It works either way. I think right now, the 3 colors, it might be easiest if you did them by color. It doesn't matter to me, but would you make 7, 4, and 3? So I'm looking at this next problem. Could you please build a 7, build 4, and build 3? I think it's probably easiest out of the cubes. You might have to work together. There are different amounts of cubes on each table. Might be able to get you some more. There's plenty of paper. You can move up to the side of the table. I'm going to grab their packets up here. So are there 2 of these numbers that we could put together first to get to a 10? I'm not going to test you. I do know that you know that 7 plus 3 equals 10. We would have the kids join it. So now they're to this friendly 10, so that they have done 7 plus 3, which equals their 10. Sorry, I've got a very funny shadow on here. I don't know where it's from. Oh, it's the shadow from the light. Then they do 10 plus 3 equals 13. Except, sorry, grabbed my wrong number.
No, 3 up and 4
Yeah, I could, yeah.
Wait.
So I did 7 plus 3 equals 10. I need to slow down, and now I've got 4 left, so I get 14. And the first couple of times, we're going to have the kids use the manipulative so they can prove it to us. Some kids are going to keep using it, some are going to see this, oh, I completely understand what you're talking about. That's the differentiation in the classroom. I'm going to let them move away. I'm going to let them. So now, do you get the idea? I don't think we need to do all 3 problems. Okay. So now we are taking it to the more abstract, or at least to the numbers level. So I've got 9 plus 3. How am I breaking that 3 apart? I'm going to have them draw the 10. How did I break or decompose that apart? I broke it into 1 and 2. So I split that 3 apart. So I have my 10 plus 2 equals 12. I'm looking at this example. This is coincidence that those 2 are the same numbers. How would I break 9 apart? Actually, I don't think I'd even ask that. I'd say if I have 4, how many more do I need to make 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's my 10. How did I break my 9 apart? I've got 6 and 3. And I've got now 10 plus 3 equals 13.
You can just take 1 from the 4.
And that's exactly, any child who quickly did that, I would say, is there a more efficient way? This is back to that commutative property. I can switch my, well, you don't even have to switch them. But yes, in fact, as we go along, I would start really asking, which way do you think is easier? And they'll go, wait a minute, it's easier to break apart the smaller number and give it to the larger. To begin with, I want them to see that it works both ways. To start jumping around in the numbers the very first time, they don't see the pattern, or they try to make it into patterns and stuff that don't exist. So yes, that would be the next move, and that might be what I'm chatting with you while she's over here still counting. Yeah. So would you go ahead and just do one more on your own? And I could ask you what are the 2 ways that it could be done, but you're going to have a more efficient way. Turn and see if you did it the same way as your table mates. So I'm going to stop here. We've made at this point in your child's mathematical career a really big deal out of this 10. It's very purposeful because our number system is based in base 10. We are choosing, right now, I may get myself into trouble with this, we're choosing to do a lot of this with 10s and other numbers when we really haven't introduced what a 2-digit number is, mostly because they've had a very hands-on experience. I think there's a teacher or 2, oh, I'm skipping a page, well, I'll finish that statement. There's not a great reason of order, whether we went and taught the kids about the place value before this. It's not a big deal. I mean, these lessons come within a few days of each other, not months apart. There are a few teachers who want to try teaching this lesson first. So although I'm kind of marching through this in an order, they may change by a day or two, how your teacher does it. So I'm going to say that, but I want to get back to the word problems. I mentioned the read, draw, write. It has become rather critical that we stop just teaching kids how to do computation or the arithmetic. And that's, we call them naked numbers now. That's the 3 + 4 = 7. Because if you don't know when to use it, there's very little value of having that fact. So we're doing a lot more word problems. And I can remember when I was in high school and you'd say the word problem and you would see all of us roll our eyes and groan. Well, we weren't given very many strategies on how to solve them. We didn't really value them because they were usually silly. I'm not sure we've gotten past the silly because we have to make up so many of them. But I do think we're doing a lot better job at teaching the kids the strategies of how to solve it. And it starts in first grade. So we are now asking kids to model it. That means they draw a picture of what the question or the story is asking. Then we ask them to explain how they solve their arithmetic. That's where they may be counting on, they may be using the manipulatives, they may be using a number line. That's how they get the numerical answer. And then we ask, is it reasonable? Now, some of the reasonableness really is, did you actually answer the question that's being asked? Because in many problems, I could ask, not the first one, I could ask a different one. So if we look at this, it says, this week Maria ate 5 yellow plums and some red plums. If she ate 11 plums in all, how many red plums did Maria eat? A child that doesn't understand the problem or situation is going to grab 5 and 11. I guarantee you they're going to add them because no child voluntarily subtracts. And they're going to add them up until 3rd grade, and then they multiply everything. Has nothing to do with the context of the story. It's wrong. So this is why the modeling is so important. It seems difficult to understand why it's so important when it's a simple problem. But this problem here is not simple for a 6-year-old. When we put part and ask for the whole, that's what they're expecting. So this one is, we have Maria. She has 5 yellow plums. And some red. Well, what do I know? I know she has some. That becomes a question mark. And they're the red. I'm not going to write plums over here. If she ate 11 plums in all, okay, there's my total. That's the information that came from the problem. So I know that this child understands what's going on. This is called a tape diagram. It is not the only way. We could have done a number bond. I knew there were 5 yellow plums. I don't know how many red plums. And I know there were 11 in all. So all I've done here is set up the understanding of the problem. Labels are very important. Your kids will be asked to label them. That's part of it. Now, is this an addition or a subtraction problem? It's both. It all depends on how you want to solve it. So this whole idea of doing a whole bunch of addition problems and labeling that, and then a whole bunch of subtraction problems, and it's especially subtraction, we were doing disservice to kids who saw how to solve it by adding up. And then I'm standing at the front and saying it's a subtraction, and we've just lost a child. There's just a disconnect. But wait a minute. I know how to add up, but I must be wrong because my teacher's telling me it's a subtraction problem. So we don't do that anymore. We say it's a problem. You've got a lot of strategies on how to solve this. So I'm going to ask you to look over here. I walked into a teacher's classroom and she had such lovely anchor charts. She goes, but they're not finished. I said, I don't care. So her subtraction one, she's up to date. These are a lot of strategies of how a child could now solve the arithmetic. So it could be 11. I have 11 plums. I know 5 of them are red. How many would I have left? I mark off the red ones and I count out. I could have done, I have 5. I'm going to count up until I get to 11. That's called counting on. I can count back. The number path, interesting, number path is really a number line. Taking from 10, we're going to do it in a little bit. So that's the way we could have subtracted. This one, I don't know that, yeah, really the only adding is going to be adding up. This isn't complete yet, but I just wanted to point out that these are over here. There's a couple more, well, there's multiple strategies. There are a lot of strategies in the world to do all of this. We have picked a resource that is research-based, and they said, we're going to teach the kids specific strategies. I'm going to accept any strategy that a child gives me. And a child with really nimble number sense or very flexible often uses part of one strategy when it works for them and then can switch to another part of another one. First grade, not so much. Our problems just aren't demanding that much. But as they get older, that flexibility of using what's best. It's not that we have an easy strategy. When we learn a new one, we throw the bottom one away. Learn a new one and throw it away. It's a tool chest. That carpenter has a hammer and a screwdriver, and that's as many tools as I know. They have multiple tools in there so that they use the one that fits the need at that time. And you and I could definitely disagree on what the need is at that time. So when we also talk about efficiency, if I can't subtract, but I can add on, somebody might say, well, that's not the efficient way of doing it. But it is for me because it's the only way I can get to the right answer. Am I going to keep teaching multiple strategies? But your children will figure out their strategies that they're going to like better. Like me, I go to this, I use the tape diagram all the time because I know what's coming in later, but I know that this one works just as well. So multiple ways of finding this, and the answer was what, 6? Could you please go ahead and draw a model for the next one? And if by chance the word fridge gets you hung up, that's a very American slang word for a refrigerator. So I've done a partial model up here, and I say partial because I do want to harp on the fact that we do need labels. And you know, we take things very easily. You know, I take the letters. I'm not trying to make the kids suffer through spelling, but I need to know that they understand what part it comes from. Beginning of first grade, we are giving them this answer statement to fill in. As the year progresses, we're going to hand that duty over to your children. Call it gradual release, that they understand its importance. We scaffold, we help them with it to begin with, but we do release that power over to them, and by the end of the year, that would be an expectation that they're writing it themselves. The last one, there were 19 dogs splashing in a puddle. Oh, some dogs left. And there are still 7 dogs. So to me, think there are 19 dogs, some left, and I still have 7 splashing. Do yours look similar to that? Okay. So as I mentioned, the place value comes along in this, if they start understanding how our number system is built, that we have tens and we have ones, they are going to be working with building it, and then these cards where it says 10 and 1, and you can put them together and you see the 11. They're called hide numbers. I'm not even sure the name of them. So that they understand that these numbers mean something. So here, I can count them. I know there are 12 ladybugs, and it's made up of 1 10 and 2 ones. We're just going to have a lot of practice with that. We want them to understand the flexibility. That is 1 10 and 2 ones, but it is also 12 ones. When they hit 100 at the beginning of in 2nd grade, they understand that 100 is 1 100, 10 tens, 100 ones, or 5 tens and 50 ones. And that flexibility of being able to manipulate them back and forth is what makes the mathematics where you can do a lot of mental math instead of being stuck at only using the number as one whole unit. So you can see this one is done, they're trying to show it. What do we have? We have a 10 and we have 5. So we have 15, and it's made up or decomposed or composed of a 10 and a 5.
It's
4.
14. I'm doing really well with my counting. So it's the same as 1 10 and 4 ones. My examples happen to both be 1 10, but yes, they'll be the expectation is that they go up to 100, and I'm a little mixed up. They may only go to 99, but in this unit that they're in, they are only going to 20. They will have another unit that goes to 40, and they will have a third unit that goes on to 100. So as we practice these strategies, we start with the smaller numbers and then build on. The next 2 problems, they're the same thing. We're still asking them to understand word problems, but we're asking them to think it through, being a little bit flexible with that number, and can they give us the answer in tens and ones. The actual solution of it is the same as the last ones we did. So if we have 4 big sandcastles and 10 small sandcastles, how many sandcastles did they make? Well, I have 1 10 and I have 4 ones. So we've just asked them to do one more process of breaking that number apart and understanding it. This one, they used the 10. The first couple times they practice, they'll probably be given problems with 10s and some others. But the next one you'll see moves on to 8 plus 7. We're going back to that, can I make something about 8 and 7? Can I decompose that 7, get a 10? And how does that relate to our number system? You want to do that one? Go ahead and do this one. Who is this? Ronnie. So I drew this one a little bit differently because I don't want to think that because I'm showing it you just one way. There are multiple ways for kids to demonstrate these numbers. And they might start by drawing circles. Stars were easy, so I did go ahead and do stars. So a child might be drawing them to begin with. This child, I would think, probably would come along and circle 10, and then have a 10 plus 5 equals 15. Then I've got my thinking that already going, that I have a 1, 10, and 5. Another child may have put the numbers in there and then shown you some other work as to how they got the answer. We do teach particular strategies, and on any given day, I'm asking your child to practice that strategy. When it comes to the assessment at the end of the unit, they're allowed to use whatever strategy they like. The reason we have them practice it is if we don't ask them, they don't move beyond their comfort zone. And if they don't practice it, they don't really gain that idea of, oh, I might like this one better, or it might be a better tool at another time. But when the assessment comes, I'm not going to care much as long as they've made their thinking visible. And that's that term that we use with the kids all the time. You make your thinking visible. So I hit on this at the beginning when we went through the vocabulary of how important it is. We now switch that equal sign, and we got all these fancy words. We put the equal or the question here. This is probably the hardest type of problem in first grade. It's called missing addend. We do that before subtraction, even though, of course, we see them as very related. They'll come to see them as related, but at this point in time, they're probably going to add up. And we would expect drawings for these. I mean, this is the first time we are seeing them do this in the teens. So I would expect some sort of, I don't know, I personally would break 7 apart into 1 plus 6. So then I can do 9 plus 1 plus 6. So I've got my 16. If a child wrote that, I would be fine with it. If a child wrote 9 plus 1 equals 10, 10 plus 6 equals 16, I'm going to be equally happy. They're both correct. What is not correct is 9 plus 1 equals 10 plus 6 equals 16. That is just mathematically incorrect because 9 plus 1 does not equal 16. I call that stream of consciousness. It is the way we think, but that's not acceptable. And we talk a lot about that in class. And it's really whether the child, I'm not even valuing one or the other, it's just kind of the way they think and see it. What we really have to strive for is in this unit, we're really good at teaching them this, and then we as adults even let it slip away because we're still not used to seeing it. So again, if you were sitting in your car at a stoplight, because of course your kids want to do math at that stoplight, you could ask them what equals 2 plus 5. So we're back to switching it around. Can they understand that it goes both ways? By the end of, I said this, by the end of first grade, your kids should be able to do up to 10 easily. The standard fluently. They need to be able to add up to 100, but that's assuming that they are using a picture or manipulatives or a strategy that might take a piece of paper, not mental math. So the mental is up to 10. In second grade, it'll be to 20. But beyond that, we're expecting them to have some sort of resource to help them. So could you figure out how would you show me your thinking on a few of these problems?
think of different ways kids might show their thinking right now. Those are probably the most common ways in your repertoire right now.
Is only writing is sufficient? Or I have to do it like, when I break it, for example, anyone, like 4 plus 8. So when I just make 4 2 plus 2 plus the 8, and then I will take 8 plus 2 is 10. So it's all in writing.
To begin with, yes. We have a pretty good judge. I mean, I've watched you develop. I'm going to allow you to take away the scaffolding when it's ready.
So for example, this one is, do you consider there's drawing here or
No, these would be fine.
this one as well? So it's
Yeah.
like how I take it.
So I'm gonna, what she's doing is she's showing me by numbers how she's breaking it apart. That's pretty sophisticated for November 16th for a child. I would say in a few weeks, that's not going to be that sophisticated. We're gonna have a lot of kids moving on to that. I also want to show, she's using parentheses. Brackets is the other word. Parentheses is the American term. We now use those, and kids have absolutely no problem with it. We do number talks, and we ask the children to explain how they did this mentally. We practice with the kids mental math, and I try, what we do as a teacher, write down what they are telling me. Parentheses means this is what I'm doing. It's often first. I've done this, first grade is as low as gone. I use parentheses all the time, and not a single child has any issue with it because they're watching me do it with the words that are associated with it, and they're absolutely fine. They're not repeating it much. I'm not seeing it transfer in first grade back to their writing, but by second grade we do. At first grade, they're still not struggling, but working pretty hard to decompose that 6, knowing what number is going to be valuable for the 7. So their brain's focused on that part. But by second grade, I've had one third grader ask me what it meant, and I asked them what it meant, and they looked at me and said, well, that's the part you're doing first. I said, and that's exactly why we do that. Because, you know, I'm writing down what you're saying. Because I actually wrote parentheses and then circled it. They're probably going to use circles at this point. So I saved the best for last. I want to show you something that is, every single teacher that looked at it first said, that's just counterintuitive, it's going to be too hard, and then we built it and all the kids picked it up immediately. We've been stressing tens. And I don't know if this is going to be easy. I would like you to use your 10 frame. Could you work with a partner and go back? I want you to have this page in front of you. I'm going to ask you to build these problems. And this is the one, it's probably, teachers have favorites too, whether they're going to do with cubes. I love these red and yellow ones. I'd like you to build 13. It doesn't matter whether they're red, it doesn't matter if they're red or yellow or mixed, but there are definitely a lot of children that would never mix the color if they had the opportunity. So the problem we are going to work on and this is subtraction using the friendly number 10. So if we need to take away 9, we're going to take, can I take away 10 from this, excuse me, can I take away 9 from this 3?
No.
Okay. At this point, we want to take away 9, if we can, from 1 10 frame. Can I take away 9 from here?
Yes.
So what did I just do? I just did 10 minus 9 equals 1. I now have 1 plus 3, and my answer is 4. I doubt that anybody in this room would have done that. They would have started at the bottom 3 and taken some away because we were taught that way. We've discovered that the kids really like this way of doing it. It makes sense to them. And the teacher's going, but it's a subtraction problem, and then they have to add. If they can visualize it, they have no problem with that. So that's why we build it, and then we draw it with the building, and then we move on to the numbers. So let's do the next one is 12 minus 8. That still equals 4, but that's okay. How would you build it? If I take my 8 away from my 10, I need to write that down because that's what I'm doing. I can now look up and I see that I have 2 plus 2, which is the same as 4. So I caught my own language there. Even though I use this equal sign, I should be using same as. I work all the way through 5th grade. Your teachers are actually better at being the consistent language because they were in 1st grade all the time. But every time I have an equal sign, I should be saying it's the same as, same quantity as, same value as. That makes sense to them as opposed to just this vocabulary word. So one last one. Would you do about 18 minus 9? I lied, that's not the last one.
They will start doing understanding it by doing, but then it will be always like, okay, I have it in my mind.
When I get stuck, I know how to go back to that visual. I'll move on to the numbers, but whenever I have a pathway to help myself when I get stuck, that's the value of the
Are they
building.
gonna take any multiplication?
Multiplication, no. Multiplication is a 3rd grade standard. Will we be doing, there'll be skip counting and groups of in 2nd grade. So my guess is you got 10 minus 1 and then 1 plus 8 equals 9. I selected those problems very purposefully. So if you were going to do 15 minus 4, what would you do? The reason I want to show you this is we are always getting even with these kids and saying, why did you do that? I would expect them to take it from the 5. So we do want them to be thinkers. We're not saying always take it from the 10. Those first 3 problems I gave you, I had skipped to the hardest type because we've got 1 more minute. So they are going to see 15 minus 4. They should take the 4 from here. So we're constantly asking them, and when we get to the other ones, why did you take it from the 10? Why did I take it from the 10? Because I couldn't take it from the 4. On this one, I'd expect them to say, oh, I took it from the 5 because I can. So again, we want thinkers because we have calculators. So we want them making purposeful decisions. So I don't know if your kids were like mine, but a walk around the block used to take 20 minutes because they kept stopping and asking, why is the sky blue? Why is the sidewalk cracked? And so now I just find it funny that I get to do it right back to them. Why did you do that way? And it's that discussion that's going to help their mathematics. We now have the brain research, and I mentioned a little bit. When your child is enjoying it, and learning is an enjoyable thing, I don't mean to say it all has to be games and whistles. Solving something that they're proud of is a big enjoyment. They will learn it better. Talking about it is a different pathway, and it helps your brain go from the short-term memory to the long-term memory, and we need that. And as the brain is developing, pre-K, K1, we need those multiple practices, because we know they can do a skill for 2 weeks, and if we don't go back to it, they can forget it. Even though they seem to have it real solid last June, if we don't revisit these things, they'll lose it. Doesn't have to be revisited in exactly the same way. Another very, very funny thing, if your child is really stuck on something and they're sitting, ask them to stand up. Your brain, again, will use a different way. I kind of feel like it's like Doha traffic. If one route is closed, you try a different route. Your brain actually does that, and that's one of these movement things, that if you stand up or walk, you're actually using a different pathway in the brain. It's fascinating what we now know. So this is the unit that they're in right now. As I said, it's pretty much repeated. It goes up to 20. It's going to repeat it to 40. That's that repetition, that coming back to it. It seems like they should just automatically get it. They don't. 40 is a very different number to them than 20. It's not, well, I wouldn't say twice as big because they wouldn't know that. But they don't just carry over the strategies. We have to prove it to them. I'm sorry, they have to prove it to themselves. That's what this is about. So when we talk about me not standing up there saying, just do it, the reason we build it, this is when they are building their knowledge. So they will get to 100. Yes?
Can you show how to do this, or how they're expected to do this one? The 8 plus days is the same as 17.
I mean, they would be welcome to show me many different ways. I think a lot of them would do 8, 9, 10, 11, 12, 13, 14, 15, 16, 17.
Okay.
How many hops did I get? They might draw 17, 2, 4, 5, 6, 7, 8, 9, 10. If your child, using this setup, this pattern, and again, our brain likes patterns. It's the 5 frame or the 10 frame, whichever you want to call it. If you get in the habit of kids drawing this, it's just a very visible pattern that's easy to follow. If your child refuses, I wouldn't make them, but I sure would keep demonstrating how efficient it is and how quickly you can read the number as opposed to counting. So I now have 17. In my head, oh, I started with 8. I'm going to get rid of 8. How many more would it take to get to 17? I would count them up. So lots of different ways.
And like number bonds, they wouldn't necessarily use on this.
They could demonstrate, they couldn't, a number bond off shows you that you understand what the question is. It doesn't necessarily show you how to get the answer. And that's a tough overlap at first grade because often it does.
Yeah.
By second grade, it won't.
Okay.
So no, you know, if they figured this is the number bond, they know they have to figure out that number, but yes, they still have to have an arithmetic strategy to get from there. Any other questions? Can I ask 2 favors? This is the first time we've done this in the afternoon. I can already tell you, you probably won't do many more because I didn't, compared to the signups, probably half the people came. Compared to people coming in the morning, it seems to be easier for people. So could you let me know how this strategy worked for you? It will ask you if you like this time. If you loved it, write that down. And then, if you would be really nice, if you could put these back away in 10s. This is what we teach your kids to do because 10 is such an important number. 6, 8, 9, 10. as soon as you have one, you can just build them the rest the same size length. But if you've got time to do that, that would be lovely, because I have to return these to a teacher, and that's the way they came. Yep, so we're putting things away. I have to return these to a teacher in groups of 10. They're doing in class. They're going to be showing these strategies this unit. They'll be practicing it for the rest of the year. I would not expect them to master all of these. Yeah. This is what they're being shown in this unit. As I said, those are the subtraction strategies. Unfortunately, she hasn't finished her addition strategy yet. And then we'll be practicing them on. So in first grade, they're expected to be able to count to 100 starting at any number.
So if I'm writing this
We would not expect them to. That's a second grade student.
so what if they
They can probably read it. I doubt, I bet I could ask them a few questions and they wouldn't understand the value of it at all. So that's why we don't go forward just to bigger numbers, because it's, just because you know a bigger number is a surface level. We don't do it just because of bigger numbers. Yeah. So, to differentiate at this point, I would probably do questions that have 3 numbers or a multi-step problem.
regardless.
Yes. We absolutely do all the research, do not believe in it. That may be coming to an end in middle school. The research is showing that up to 6th grade, the tracking of kids by ability is fairly false and leads to problems. Now, that's what I'm saying. Yes.
So the one I see right now used to have
You know, I don't really know enough. Some of it is they've switched the ones and they just found that, you know, I've heard even from some conversations, they may not have honor geometry, they're probably offering something else. You know, well, whether, I know that they needed to bring in honor stats, they thought was a more valuable class. Through 6th grade. Now, that's not to say at any given moment, I don't ask you to do more, but I'm not just doing it because it's 2nd grade. And these are skills. At some point, I'm gonna, like, something like you, I'm gonna try to give you logic problems or puzzles. So it's not exactly what we're doing here, but you've already shown me that you know here. I'm not gonna waste your time doing that. A lot of kids who have the skill to get me that answer quickly can't explain it to me, you can't draw the picture, and I am going to make them do it. Yeah, but I am going to make sure that they can model it and explain it. I just know not a good enough answer. I mean, yes, 2 plus 3, I get it, you just know it. But then what are you doing when you're having 12 plus 8? Do you understand that there's a limit? And a lot of kids can give me the answer, but they don't know what's going on. So I want to say thank you. I am here for, you've got to get your kids. You know, I'm here for another 10 minutes. Something just went through my brain that was brilliant to tell you, and I don't know what it was. Yeah.
We have.
Yes.